with graphs, come up with tables. When you come up with graphs, we first come up with, we come up with a table, okay? Or we call one we call the frequency table. Then from the frequency table, you can draw the pictographs, okay? The pictograms or the pictographs. Then after that, you can come up with a bar chart, and also you can come up with a pie chart, okay? So these ones, all of them help you to answer a particular question that you will be wanting to find out. So based on the information that you will get from your pictograph, okay, so we're saying that based on the information that you will get from your pictograph or from the bar graph and then the pie chart, you'll be able to conclude, okay? You'll be able to carry out a conclusion to say whether your information is true or it is false, okay? So that is what we mean by collecting data and then carrying out what we call a hypothesis. So I want you to keep trying out more numbers, and you see how you can easily carry on your data collection. Okay, so when you get data, any data that you collect, please make it a point that you pick meaning out of it. Okay, and that is by coming up with what you call the hypothesis. Okay, Isaac, you have something to say, or you try testing your something? Isaac, Hira, Isaac. Okay, all right. So today I would like us to start on something new, and it's also going to take us quite a short period of time. And this is what we call sequences and patterns. The sequences and patterns. This is our topic today. Sequences and patterns. Now, dear members, whatever we look at, we try to ensure that in our day-to-day life, we make use of it. Just as in the previous topic, we've seen that when you collect data, you can find out whether something is true or false. If they have maybe accused a certain group of people doing something, you go there, collect that data, make analysis on it, and then you can give your report based on what you have found out, okay? So that is how it is being used. Now, in this topic also, when we talk about sequences and patterns, we are going to look at how we can try to identify patterns. We shall also look at a rule for generating given patterns. There are certain rules that we need to follow, which we are going to learn. Then we shall also determine given terms in a sequence and also find missing numbers in a given sequence. Okay, so these are the key issues that we are going to look at. But most importantly, we need to know why are we looking at this and how can it help us in our day-to-day life. Okay, now we are saying, let me request someone to read for us. Someone to read for us here. Okay, Patrick. Patrick, read for us.
Patterns are a set of numbers arranged in a sequence such that they are related to each other in a specific rule. These rules define the way to calculate or solve problems. The ability to recognize and create patterns helps us make predictions based on our observations.
Thank you so much, Patrick. So we are saying that when we talk about the patterns, we are talking about a set of numbers, okay, that is arranged in a given order. A sequence can be any order, okay? A given what? Order, such that they are related to each other, okay? They are related to each other based on a certain rule, okay? They are related to each other, but in a certain rule. Take an example. If you have numbers like, let me write here, like if we have numbers like, you write here 1, 2, 3, 4, 5, 6, and so on and so forth. Now, from what you see these numbers here, 1, they are in order, okay? They are in order. 2, they are related to each other, okay? Related to each other. That's the second thing. And the third thing about these numbers is that they have a rule. They follow a specific rule. They follow a specific rule. That's one thing we observe about these type of numbers. So when you have a set of numbers, as we said, first they are a set of numbers. Okay, this is a group of numbers. The way we see them here, it is in a group or a set. We learned about sets. So that is one. Secondly, you can identify that they are in order, maybe from 1 to 2 to 3 to 4 and so on. So meaning they must be in a given what? A given order. And there is a relation with each other in that when two items are related, it means that one can determine the other, like the other one can help you to find another. Okay, and there is a specific rule in which those numbers are for. Like if I want to find out the next number here, there is a rule that I will follow, and that rule will help me get other numbers. So this is what we are looking at as the patterns. Okay, so these are the three key things that we pick from numbers that are in that arrangement. Okay, now look at something here. This other part. These rules define a way to calculate and solve problems. Now, the ability to recognize and create patterns helps us to make predictions, okay? Based on what? On an observation. Now, when you see those of us who would like to be in certain field, in different fields, there is maybe take an example. If you want to work maybe in a meteorological center, okay, where they monitor the climate, and then the weather changes. Okay, now those people there, they use sequences and patterns to come up with a prediction of the next. So for example, they can say, last week it rained. The other week on Tuesday, it didn't rain. So they can use that to tell you that now, in the next 5 days, this is what is going to happen. In the next 2-3 weeks, this is the weather. So you'll see that they are going to use sequences and patterns, okay, to be able to carry on a prediction, okay? So one, in predicting the weather and the climate of a place, we use sequences and patterns. So that we say that if it is this, if for example, if we want to find out the weather on a certain day, maybe on a Wednesday, okay, they will look at all the other Wednesdays behind there. On a certain Wednesday, it rained. Another Wednesday, it rained. Another one, it rained. That means automatically this other Wednesday it will also rain. Okay, so this is what we use. Who knows any other place where we use where we can carry on predictions based on that sequence. Any other place or any other area where you can find those predictions there for numbers? Yes, Fatuma.
On airports.
How? Airports, how?
By predicting the amount of wind which is going to blow in a day.
Oh, they are predicting the direction of the wind. Okay, direction of the wind. Okay, so maybe we could also put it under that, under the climate. Okay, good. Another person to give us an area where we can see, where we see these predictions happening. Enoch? Enoch?
In construction sites.
How?
By predicting the number of bags of cement.
Okay, construction sites, eh?
Yes.
So they say since the other house used the 10 bags, this other one used the 20, so this one will use this, eh?
Yes.
Okay, good. Thank you. Let me have another. Andrew Chimera.
To be able to in the army, to be able to attack enemies.
Yeah, so they look for the enemies also. So they say, since the army, the other time they attacked from this other side, this way they did like this, so meaning this other time they are going to use this. Good. Let me add another. Daphne? Daphne? Yes.
School attendances.
How?
By predicting the number of students who have attended and those who have not attended the class.
Those who have attended, we say that today if they attended 10, then tomorrow they will attend this number like that, eh?
Yes.
Okay, thank you. Can I have one more? Shadia. One more.
Teacher, water transport.
How?
By predicting the direction of waves.
The direction of the waves, eh? Okay.
Yes.
Good. So, dear members, in summary, we've seen all those areas in which we can be able to tell, that you can easily tell the weather changes by farmers. I think we've talked about that, but what is more important, by the way, even you, okay, you can even use this one here. Let me give you an example. You see these papers here that we carry on, those of you who have answered examinations, you see that we start PLA. When you're sitting PLA, before you sit for it, you go and read for papers of 2012, you read papers of 2013, up to 2019. Then in your year, you can tell if they brought this, since they brought this one, then they brought this one, that means they are going to bring this one here as well. Now you've calculated based on a sequence. It means you've looked at those predictions and then you've come up with your result in the final end. Okay. Even me, I can also predict your results as well. I can say, since Joy today got 20, in the next one got 30, another one got 40. I can tell from here that the next one automatically she's going to get 50. Okay, so you'll see that you will use what we call the sequences and then the patterns to be able to predict that. So that is why we are looking at this. The ones I've told you are live examples that you can see, but there are other much more that are there that we shall be able to learn from. Okay, so take an example. When you have these numbers here, look at these numbers that we have. We have numbers like, we have 3, we have 6, we have 9, we have 12, and 15. So from here, based on what you see here, you can tell, if the first one I started with 3, then they went to 6, then they came to 9, then 12, then 15. Do you know you can now tell the next 2 numbers here based on what you've seen here? You can tell the next 2 numbers. Who has already seen the next 2 numbers? Who has already seen the next 2 numbers? Jotham. I hope Jotham's network is okay today.
Yeah. Yes.
What's the next?
Okay, so I'm here.
What's the next number there?
It's 18.
It's 18.
21. After 18, 21.
You have 18 and 21. Okay. 18 and 21. So you see that you may ask yourself, how has Jotham got 18? How has he got 21? But he has used these numbers here. He has used these ones here, the former ones, to be able to predict this other number here, these other 2 numbers. Okay. So what are we learning here? What we are saying is, for now, we are not looking at how we are coming to the 18 and then to the 21. What the knowledge we are having here now is, when you have some numbers already given to you that are in order, okay, they are being in order, they have a certain rule that is being followed, it means you can be able to get the other numbers that will follow at the end of it all. Okay, so that is what you see, that you can even predict those numbers directly there. Okay, so that's what we should be knowing as far as this is concerned. Now, moving on, let's also go to another. Now we have a big table here. Look at this table of mine. Okay, you see when you look at when you look at these numbers here, you can now tell. Let's answer some things from here, maybe together. We are going to answer something together here. So let's observe these numbers here. There are numbers from 1 up to, I think, up to 100. Okay, I have numbers from 1 up to 100. Okay, I have numbers from 1 up to 100. Okay, now, sorry, we have from 1 up to 100. Now, let's look at our question here. Look at this. The square shows multiples of a number. What is this number here? The squares are these ones here that are in yellow. See these ones in yellow? I hope we are seeing them. You see these ones in yellow? So we are saying they are multiples of a number. Which number is that? The ones in yellow, we have this, we have that, 4, 16, 18, all of them up to the last one. They are multiples of a certain number. Which number is that? By show of hands. Which number is that? Rodney?
Teacher, it's 4.
Hey, it's 4. They are multiples of 4. How did you know?
Every number, starting from 4 itself, if you keep adding 4, you get the next number, teacher.
Hey, so so this is what he is saying, that every number, when you add the 4, you get the next number. Okay, let's prove this one here now. Let's prove Muchivi is saying. He's saying that every number that is inside here, he said every number that is in here, starting from 4, when you add the 4, you get the next number. Okay, so look at, we started with the 4. So 4, when you add the 4 plus 4, you get 8. and 8 is the next number. I hope you have seen it. When you get 8 plus 4, you get 12. Is 12 the next number? Yes. Okay. When you get this 12 plus the 4, you will get what? You'll get 16. Is 16 our next number? True. Okay. When you get the 16 plus 4, plus 4, we shall get 20. Is 20 our next number? Yes. So all these ones here, you can even prove for the rest that you realize that now our 4 will be the multiple that we are looking out for, because when you get that 4 and you add it to every number that is highlighted here, will always give you the next number in the sequence. So you can see how we can easily predict. Okay. Okay. Someone is giving us another reason. Any other reason apart from the one Michiba has given us? Any other reason apart from what Michiba has given us? Any other reason for choosing 4? Yes, Melody.
I choose 4 because the numbers that are highlighted are in the table, are in the multiplication table for 4.
Meaning, what happens? How can it help you to get the next one?
Like you add each digit plus 4, then you
Plus
get
4. Okay, the way we have done it here. Okay. Good. So we are asking for another method, another reason apart from the one which Chibi gave us. Yes, Nansuga. Nansuga Gloria.
I divided each identified number by 4.
What do you get? 4 divided by 4 is 1. 8 divided by 4 is 2. 12 divided by 4 is 3. 16 divided by 4 is 4. So what do you draw from these numbers here that you get? Gloria?
Yes.
What happens now? We have divided. Give us a conclusion now. Okay, someone to help us here. Yes, Elnora? Yes, Elnora?
Yes.
Yes, your hand is up.
We get these numbers by multiplying them by 4.
Sure. Which one?
4. If you multiply 4 by 8, it gives you 4 by 2. It gives you 8, and 4 by 1 is 4.
There are 4.
These are multiples of 4.
Multiples of 4. Okay, understood that. Good. Angel? Angel?
These numbers are divisible by 4.
They are divisible by 4.
Yes.
Okay. So the other thing that we do have is that these numbers here, all of them highlighted, are divisible by 4. That when you divide them by 4, you don't get any remainder. Okay. So these are the two reasons that we can put across, that they are divisible by 4, and also when you add 4 to them, you come up with the next number in the sequence. Okay, good. Who can now we have that 4. So from there, we can now complete the other things. The 12th multiple, the 20th, we can now see from that table there. Okay. Now, as I said, you can now easily tell the next numbers in the sequence because of the other previous numbers that you do have. Okay. Now we are here. We need to generate. Okay. Whatever we need to do. Okay. I didn't understand very well. Who is this? Resty. Which topic is this, Kwesiga? We are looking at sequences and patterns. Hope you're there. We are looking at sequences and patterns. Kwesiga, you're asking, yeah? Sequences and patterns. Okay. Now, you can be given numbers and you are required to find the next ones in the sequence. Now, our problem here that we have is what method shall we be able to use? Okay. What methods shall we be able to use to be able to get, for example, if you have these numbers here. So if you have these numbers, what method are you going to use to be able to come up with the next number in your sequence? That is the other thing that we need to learn. Okay. So take an example. We are saying we have, for example, we have 12, we have 17, and you have 22. And they are telling you to find the next number in the sequence. Okay. What are we supposed to be doing in such a case? How can you be able to get the next one in the sequence? Can someone help us here? How can we be able? Okay. How can we get the next number in the sequence here? Okay. Diana and Daure.
Yes, teacher.
How can you be able to get the number there?
Since the numbers are increasing, I think you add them. You get a difference between the first number and the second number.
So when you realize the numbers are what?
Increasing.
Are increasing. So if they are increasing, it means we are doing what? We are adding. So what are you doing here?
You're going to subtract. You're going to subtract the first number from the second one. 17 minus the second one is 17, then the first one is 12.
What do you get here?
5.
You get 5, okay. Then next?
Then the next is 22 minus 17.
Minus 17, which is what?
12.
Which is what?
No, 5.
Which is also 5.
5.
So what will the next one be?
You now add 22 plus 5.
It will now be 22 plus the 5, and it will be
27.
27. Good. Thank you, Diana. So, dear members, as we have seen here, what are we first doing? You first identify, is the number increasing or is it decreasing? Are we together? This is the first thing you need to do. First identify, are the numbers increasing or they are decreasing? Or they are just in a mix-up. By the some others are both increasing and decreasing. Yeah? Others are increasing and decreasing, or both. Okay? So after realizing that, what do you now do? First of all, here we have seen our numbers are increasing. Okay? Meaning we are adding something. We are adding something. So what do? You first, how do you get that number which is increasing? You first subtract this second number minus the first number. Okay, this is our first, second, and third. So you first do that subtraction. Why are you subtracting? You're subtracting to get a common value that you are going to add on to the next one. Okay? That's what you're doing. You're going to get the next one. You know, the skills, by the way, we are acquiring is prediction skills. Yeah? These are the skills we are acquiring of predicting items and accurately, okay? Doing the right and accurate predictions. So after doing this, after doing the subtraction, you will realize that there is a common value which is there. There is a common value that is there. So our common value here is 5. So automatically, in the next one, we shall have 22 plus the what? Plus the 5. So meaning here you'll get 27. So from here you can even predict the next 100, the next 200, and so on and so forth. So the next one you'll be getting 27 plus 5, and you get your answer there. Then we continue on and on and on. Okay? So this is the first thing we need to do. We have two things that we do. One, identify, is the number increasing or decreasing, or it is both doing so the same thing. Then from there, you can, by the way, sometimes it's, when it is increasing, you are going to add. When it is decreasing, you're going to, here you'll be adding, then the other side you'll be subtracting. They keep on interchanging as well, okay? So that is what you'll be having as well. Let's look at the other one. I know someone has even already done the second number. We have 50, we have 45, sorry, 47, not 45. Here we have 45, we have 47, then we have 44, then we have 41, we have 38. We need to find the next two numbers here. Okay? Who is giving us the next two numbers? Who is giving us the next two numbers? Victor, Isaac, Christine. I don't know who is giving us now. I want Isaac. Yeah, I want Isaac.
The number decreasing.
Yes, teacher.
35.
Isaac,
35. 35.
Hey, Isaac. Isaac was up there.
35.
How did you get the 35? Want to know how?
The numbers are decreasing. You get that one.
Go slow, Isaac. The numbers are decreasing. Yes, that is one. So
you get
50 minus 57.
Isaac, are you still with us?
Yes, I'm still with you.
Good. So
50 minus 47.
50 minus 47. You get
3. You get 3.
Good. Then
47 minus 44.
Minus 44. You get
3.
You get 3. This is enough. So what do you do here?
38 minus 3.
38. 38. Hey, Victor went off. All right. Mercy, can you complete? Mercy, you can complete. Mercy. Okay.
Shall
Is
get.
Mercy?
Yeah.
Continue from here.
Shall get 38 minus. No. 38 plus 3.
Plus, why plus?
38 minus 3.
38 minus?
Minus 3.
And we shall get?
36.
36. Then the next one?
Then we shall get 36 minus 3. Then we shall get 33.
33. Okay. Thank you. So you will see that at the end of it all, so here we shall have 36, and then we shall have 33. And we shall keep moving on and on and on. Okay? So dear members, what are we trying to look at? When you are predicting something, first see how we first get that common value. Okay? Something is wrong somewhere. She's not correct, she's not correct, she's not correct. Good. We have some people to help us here. This is 35. Okay? 38 minus 30 minus 3 is 35. Then here we shall get 35 minus 3, which is 30, which is our 32. I think this is what we have. Good. This is what we have. So from 38, we shall come to 35. Then from 35, we shall come to 32. Okay? I think it is that is what it is like. Yeah? There is someone had subtracted wrong over here. So this is what we shall be having at the end of it all. This will be our next two values. Okay? So before you predict, before you conclude for your next prediction, ensure that you come up with a given order of the values. Okay? Now, members, from this point here, we now generate what we call, a formula. Okay? I know you can now get the rest. We can now get the rest. If I gave you these ones here, I know you can clear all of them. These ones here. Let's work together. I want one by one person at a time. From the first, second, third, fourth, fifth, sixth, like that. Okay, we are going to work out 1, 2, 3 only. 1, 2 up to 3. Let's start. Who is working out A? Who is working out A? Who has not spoken? I need people who have not spoken yet. Mukasa? Yes, Mukasa. Mukisa, sorry, not Mukasa. Mukisa is not there. Blessing? Blessing?
Yes, teacher.
Please give us for the first one, the next one value.
78.
78. How did you get it?
I added 12.
What is the 8? Is 12, eh? So
Yes.
this one is 30 minus 18, which is 12, eh?
Yes.
Then we have 42 minus 30, which is 12, eh? So
Yes.
this one will be 66 minus 66 plus, plus 12, which is will be 72. Good. Thank you. Got that. Next one, Abby. Next one is Abby. Hey, or both?
Yes.
Both Abraham.
Yes.
Next one.
The next one I got 4.7 minus 4.6 minus 4.1.
4.7 minus
are
4.1, which is
6.
You get 6?
You
Or
get 0.6.
0.6.
So the next number will be 7.1.
So how did you get this? So it is 6.5 plus,
Yes, plus 0.6.
0.6, which is it?
Which is 7.1.
7.1.
Yes.
Okay. Thank you, both. So you can now get the other ones, but we've seen how the order is, okay? The other ones you can now follow and then come up with the other. It is 78, not 72. Where is this one? Sorry, this is 76. This one here. I think this you're meaning this one, think you're meaning this one. This is 78. 66 plus 12, it is 78. Okay? This is 78, not 76. Okay? Okay. Please, you can type in now the rest, and then we get the other sequences that are there. We can easily get that as well. Now, finally, what we need to know is how do we generate a formula for all that so that we don't stress so much using the head. You need to find out, subtract, divide, and do that. We can generate a formula. Okay. Muchibi says C is 38. Okay, I've seen that one. Patsy is 38. The other ones can also check it out. D is 48 here. Second, first, I don't know where the 43 is coming from. Okay. And the second one, Abdul, the second one we are subtracting. Yeah? The second one we said 4.7 minus 4.1. We say it is 0.6. So meaning we are adding 0.6 to this. So the final one will be 6.5 plus 0.6. So we are keeping on adding on 0.6, 0.6, 0.6. Okay. And that's how we came to 7.1. Okay. That's how we came to 7.1. Okay. C is 26. Okay, so what I want you to do is to please go through these ones, following what we have, what we've worked through together. Now, let's finally look at this. How do we generate now number sequences? We need to work backwards. Here, much as we are looking at how you can predict numbers, but you can also create your own prediction. You can also create your own sequence based on given numbers. If they tell you create a sequence of this given type of numbers, what are you supposed to do? Create a sequence of given type of numbers. So what you do, if you're supposed to create a sequence of numbers, okay, you can generate a formula, okay, and this formula has what you call an n. Now here in the formula, when we talk about n are values. We can start, they can be from 0, or most cases from 1 onwards, 1 to 2 to 3 to 4 onwards. They are numbers that are increasing. Okay, so if they tell you to generate a sequence based on those numbers, for example, if we have from what our example there, if we have 5n and they are telling you to generate sequences, okay, sequences from n equals to 1, 2, 3, up to 4 onwards. And they are telling you to generate sequences. Now, what they want you to do is get this number. 5n means that 5n means 5 times n. And the n are these numbers that we have here. So meaning, for n equals to 1, we shall have, this will be equal to 5 times 1, which is equal to what? To 5. This is our first number. When they talk about, you go to 2, you go and substitute 2. We come to 2. Then we say 5 times 2, which is equal to 10. You come and substitute 3 for n equals to 3. We say 5 times 3 is equal to 15. Then you go and substitute 4 for n equals to 4. We shall have 5 times 4, which is equal to what? To 20. Class, what are we doing? We are now looking for sequence of numbers. We are now looking for sequences. The other time we have been having sequences and we are predicting the next numbers. But now what we are doing, we are trying to generate now sequences based on a certain what? On a formula that we are given or that we have. So therefore here, your sequence of numbers will be, the sequence will be 5, 10, 15, 20, on and on. So you can even predict the next one. The next one for n equals to 5. We say this will be 5 times 5, which is what? Which is 25. Okay? You can even generate the next one and on and on. But they can even, now, how about if they tell you, generate the 100th number? Yeah? For n equals to 100, you'll just say, this will be 5 times 100, which will be 500. So that number will be 500. Okay? So that is how we keep on with the prediction. Okay? That's how we keep on with the prediction. On and on. Okay, let me answer some questions if there are any here. Mercy, you have a question? Hey. Mercy, you have a question?
No.
Okay,
I wanted to add.
Okay. Anyone with a question? If you have a burning question, yes, Angel.
Teacher, for me, I wanted to ask a question that how do we know that these ones are square numbers, cube numbers? Okay, like that, prime numbers.
Yeah, now that one is in another topic. We're going to look at that in another topic.
Okay.
Yeah, that one is within another topic where we look at those given type of numbers, square numbers, cube root numbers, and so on.
Yes,
I think
teacher.
there was something also with the magic square. We will get that one. There's some other topic where we're going to look at them as well.
Okay, thank you, teacher.
You're welcome. Chantal. Yes, Chantal?
Teacher, I was asking, how should we get the work from the Google Classroom?
Okay, we are going to get to that as well. Jotham?
Sir, what if it is in a decimal form? What if they say 1.2n?
Hey, good. If they tell us if we have, Jotham is saying, what if we have decimals? We have 1.2n, okay? And they tell us our n is always defined. Usually n, when they talk about n, usually it is from 1, 2, 3, 4 onwards. So it's the same thing. 1.2n is equal to 1.2 times n. So this will be equal to, for n equals to 1, we shall have 1.2 times 1, which is 1.2. Okay, you come to the next one. For n equals to 2, we have 1.2 times 2, which will be 2.4. So you continue in that even form. But at the end of it all, please, you write your sequence as 1.2, 2.4, 4.8. Is it 4.8? I think 4.6. This is 3. Okay. This will be about, I think it will be 3.6, and so on and so on and so forth. Okay. So it is okay as long as there is the n that is there. You just multiply it by that. Okay. All right. I think that's noted. Fatuma.
Teacher, what if they bring a question which is saying that n equals to 2, n equals to 2, x equals to y plus n.
And y plus n?
Yes. Then y equals to 3. And A equals to y plus n plus x. And they say find the numbers. Part A is find the numbers.
The numbers, okay? So
yes.
So the numbers, the final one is actually this one here. We already have, we need to get, we do the substitution. No? We just do the
Excuse me,
substitution.
teacher.
Yes, yes.
And part B, they say that use those numbers to create a sequence.
So this is what we are looking at. So if we have such, we have our n, which is known. Okay, we have our known n. We have our x, which is here. Now, usually the final one is this one here that we are having. So you first do the substitution. First get your x. So when you get your x, x will be y, which is 3, plus the n, which is 2. So your x is what? Is 5. Okay? So you substitute it now in this one here, in the A. So our A, remember, it is y, which is 3, plus n, which is 2, plus x, which is 5, which will be equal to 10. Okay? That is what you have. Now, usually, I don't know what is the, if you're to generate now the sequence for A, remember this n is changing. Our n is the one which is keeping on changing. So we can start from 2. Meaning that this one is the last one, the least number. Okay, so we can also substitute for n equals to 3. The other ones remain, this y remains constant. We keep, you just keep adding for 3. So if it is for 3, you also come and get for x first. X will be equals to 3 plus 3, which is what? Which is 6. Then use this x here to be able to get your A. So your A will be y, which is 3, plus n, which is 3. Remember, we've changed our n to 3. Then plus x, which is 6. So your A here will be 12. Okay? So you realize that your sequence is going to start with, our first one was 10. So it is, we are starting with the 10. Then we are moving to 12. So from here, if you want to go to 4, you still substitute for n equals to 4. Okay? You first substitute for n equals to 4. Carry on the same process, and you're able to get the what? The next number in that sequence there. So that's what you're supposed to be doing. So what you do, you keep on changing your n, keep changing your n, keep changing your n, based from the first one to the very last one that you have got. Does this method apply to all numbers? Yes, it does. It applies to all numbers. It doesn't apply on all numbers, whether they are fractions, whether they are decimals, it will apply on all numbers. Okay? All right, let's predict some numbers here. Let's predict some sequence here before we come to a close. We have little time left. We have something here. Now, we said, what sequence do we generate from using these numbers here? For n equals 1 up to 5. We have n minus 5n minus 1, 6n plus n. Okay? 6n plus 2, sorry. So what you do in this such a case? So I said 1, we've been given our n. Our n is 1, 2, 3, 4, and 5. And our formula is 5n minus 1. Okay? So do the substitution. For n equals to 1, we shall have 5 times 1 minus 1. Okay? Which will be equal to 4. Okay? Then you come for n equals to 2, it will be 5 times 2 minus 1, which will be equals to 9. Please you confirm these answers. So then we also have n equals to 3, it will be 5 times 3 minus 1, which is equal to 14. Okay? Then for n equals to 4, we shall have 5 times 4 minus 1, which is 19. Okay. Then finally, for n equals to 5, we shall have 5 times 5 minus 1, which is equals to 24. Please, after writing all this, don't stop here. Yeah? Don't stop here. Go and rewrite your sequence. So your sequence will be 4, 9, 14, 19, 24, on and on. That is your sequence that you are having. Okay? That's the sequence that you have. So the only thing, you see that the only thing we are varying, here is this one here. You see that it is only this n here which is varying. Okay, see this? It's only our n which is varying. The rest are what? The rest are constant. The 5 is constant, the minus 1 is constant, while the rest are keeping on varying. Okay? So you have said y is equal to 3. Where does the 3 come from? Hey, this other one, you're talking about this question. This one, it is someone who gave it to us that we were working out. I think it was Fatuma who gave us a question. She gave us the y. That's why we gave it. There was someone asking, where is the y coming from? Fatuma gave us this question here. So it is what we're working on. It was already given. Okay. So can you work out for the other one? You're going to give me the sequence. Work out this one here and give me the sequence in a message, in a chat. This one here. For 6n plus 2. For 6n plus 2. Write the sequence and you type it in the chat. As I answer some questions as we close. Let me answer some questions as we close. Before we go for lunch. Yes, Joy Janet. JJ.
Teacher, can they also give us fractions in generating sequences?
Yes. I said we can have fractions. Okay. You can even have decimals also. You can also have decimals. They can also be there. Okay, yes, Victor Isaac. I don't know, Victor Isaac. Koshaba? Victor Isaac and Koshaba. Christine?
So you get 6 times.
Give us the final answer. Type it in the chat, the final answer. Type the final answer in the chat. I want you people to type the final answers in the chat. Yes, Prudi. I want those with questions. Prudi?
I wanted to give the answer, but I've already given it.
Okay, okay. Thank you. Thank you. Queen Shirley. Queen Shirley.
Yes, teacher.
Yes.
What makes this n change?
What makes it change is the one that has been given. This n minus this one here is what makes it change.
Okay.
The one that has been given. It's the one that makes it change. Rusty, finally, Rusty.
Excuse me, teacher. Like
yes,
5.
Pardon?
5.
You're giving the sequence?
Yes.
Okay.
5, 10, 15, and a dash. Teacher, do we use 5? We just use 5 and the number, We just only use 5. The first number.
To do what? You want to get the next number in the sequence,
Yes. Yes.
No, we said here what you do, subtract this one here, okay? 10 minus 5, you'll get what? 5, okay?
5. Yes.
Then you come to 15 minus 10, eh? 15 minus 10, you get what? 5. So this means that every number is increasing by 5, okay? So meaning the next one you say 15 plus 5, which will be 20.
Teacher,
So this, yes.
I just want to know, or you write like 5 times n, you write 5 times 1.
5
times n. Yes.
Oh, for you, if you have this one here, if you already have the 5n already, okay? You just say your n starts with 1.
Yes.
Okay? N is equal to, it starts with 1 to 2 to 3 and so on, okay? So you just substitute n for 1. 5 times 1, you maintain the 5. 5 is constant here. It doesn't change. So 5 times 1, it will be 5. 5 times 2, with these 2 here that we have, it will be 10. Then 5 times these 3 here that we have in our sequence will be 15. So automatically the next one will be 5 times what? Times 4. So you predict and know that it will be 20, which is that.
Okay, thank you, teacher.
All right, you're welcome. Okay, dear members, we have, okay, people have given us the next numbers. Please confirm. I'm picking out from Olum David Bankene's answer. Has 8, 14, 20, 26. Is it 26? 32. Uh-huh. Uh-huh. Everyone has given us. Can we confirm our answers clearly? 8, 14, 8, 14, 20, 26. 26. Adding 6, the same as my, okay. Let's work it out together. It seems people are getting different answers in their sequences. We are here. Seems people are getting different answers. So for n equals to 1, for n equals to 1, it is 6 times 1 plus 2, which is 8. I think most people have got 8. Then we go to the next one, 6 times 2 plus 2. This is 12 plus 2, which is 14. Then for n equals to 3, we have 6 times 3 plus 2, which is what? This is 18, 20. For n equals to 4, we have 6 times 4 plus 2. People are finding issues in multiplication. So 6 times 4, we have 24 plus 2, we have 26. Okay. Then for n equals to 5, we have 6 times 5 plus 2, which is 30, which is 32. And we're close to that. All right, so that's how we are supposed to come up. Now I'm going to post more work in the Google Classroom. Your exercise is here. Actually, I'm going to put it there. You're going to work out for this and also this other table as well. Okay, and then we will be having that. Okay, dear members, I think our time is fast spent. We are 10 minutes beyond the lesson. I want to thank you for being part of the class. Let me answer a few questions before I go. Arinda, Elizabeth? Arinda? Arinda?
Teacher, I would like to ask, like, if there was like 6n times 2n What would be the answer?
You just keep changing the n. Eh?
What would be the answer?
If n is 1, you put 1 here and also 1 the other side. So it will be 6 times 1 plus 2 times 1, which is 8. Got it? So if it is n is equal to 2, if it is equal to 2, you do the same thing. 6 times 2 plus 2 times 2. Then you get the answer. Okay. What else? Miracle? Miracle?
No, I'm sorry, teacher. I forgot to put my hand down.
All right. So, okay. So, dear members, we can call it a day for today, unless Teacher Charles has something to us. Unless Teacher Charles has something to us. Okay.
Oh, thank you so much, Jones, for winding up with these guys. I will do encourage them that live lessons are ending, but we shall continue with making videos for you, for maths, for physics, biology. So what you have to do is to subscribe onto the YouTube channel so that you'll be getting updates, because sometimes we may not communicate to you. The purpose of subscribing is every time when we put new videos, you'll be notified on your Gmail that a new video has been uploaded so that you go and watch. So it's only live lesson that's ending, but other program will continue. We shall continue creating contents for you. So that's what I have, Teacher John. Thank you so much for being a good teacher. I've been following your lessons very well, and I know the learners, you have benefited also a lot. So we shall always be in touch. I wish you success in your math lesson, math exams, and Teacher Jones, may God bless you.
Teacher Charles, okay, Teacher Charles.
Yes, please.
Okay, I thought we would get a group photo for all of us as a class. I don't know if it is possible.
Let me have this. Okay, a moment. Are we still together, Teacher Jones? Let them turn their camera on. I'm going to enable the video, and they can turn it on. You can take it from using your laptop.
Okay, so dear learners, let's
so the video is already on.
Good.
Yeah, the
Some of you
video
have never
is
seen
on,
the
and
person
also
teaching you up to now, eh? So you can possibly have the
so you
chance
better see
to see the person who has been teaching you all throughout.
Oh, wonderful.
Okay.
The person
So
is
we
good,
go
really.
to go. You can now make sure all of your videos are on so that we can Blessing
I'm
is
there.
not there, Daphne is not there, Chantel.
So my video is not working.
Why not? Chantel.
So my video is not working.
You're unlucky that you're not going to be able to. You shall not be able
It's not working.
Yes.
My video.
Pardon?
My video is not working.
We shall not be able to see. We will not be able to see you.
Everyone.
We will not be able to see you. Okay. There's some other people I need here.
Yes.
Joyous isn't working.
Okay.
Hello, teacher.
Hello.
Top 7.
I've not seen who Blessing is there. I've seen
Auntie told me to go on the particular class.
who else? Rodin is there. Okay. And the Teacher Charles is also there. Okay. All right. Thank you.
Hi guys. Hi teacher.
Bye. Bye-bye, teacher.
Miracle.
Able to see everyone.
Bye-bye, guys.
Okay. Let's wish you well as well. All right. Thank you so much for being part of the class and wishing you well. Exams are there. Exams are there, so please see why you're there. Okay? All right. Wish you well and have a good day.
Who's that one who has brought the whole family?
Good day to you all.
Tina. Yes. Tina. Yes.